So 3-1 quiz, here we go. Number 1 is David Hilbert. Someday on a test, I'd want to spell his name right. I would think you could spell David. If you can't, talk to David. Hilbert is H-I-L-B-E-R-T. H-I-L-B-E-R-T. Things about him, this wouldn't be the exclusive list. There might be things other than this that you have that are perfectly fine, just to demonstrate you read the thing. This is what I thought the most important things about him were. One would be he's around the year 1900, so he's relatively modern, not from like a teenager's point of view, but in terms of a historical point of view. 1900 is not that long ago. Euclid, memory of when Euclid was?
Isn't he like 2nd century?
BC, yeah, he's back in the BC, 2nd century, 3rd century BC kind of stuff. So he's way back there. Hilbert's a little bit more in our time period. He wrote a book called The Foundations of Geometry. So he said his book was called The Foundations of Geometry. That'd be good. His basic point, the main reason he made it in this book is he fixed some flaws in Euclid's book. So from the BC days of Euclid, you know, things changed. They figured some stuff out, a little bit more knowledge on hand. So Hilbert around 1900 is trying to fix the Euclid mistakes that were made. No disrespect to Euclid, he did a nice job setting it up, but Hilbert cleaned it out a little bit for him. Another thing that's worthwhile was probably that he had a lecture series he did in Paris. It was called The Problems of Mathematics. And what he was able to do and be, I described him in my own words as a jack of all math trades. So we'll see if anybody knows from the English language, what's a jack of all trades? What does that mean?
Good at everything,
You're
but
kind of
not like a master of
Yeah, you're
anything.
kind of good at everything, but not a master of anything. That's perfectly right. So a jack of all trades might be like some guy you know that there's something wrong with your plumbing and he could come fix it, but he isn't really a plumber. There's something wrong with your car, he could fix that too, but he's not really a mechanic. You know, there's something wrong with your air conditioning, he can maybe fix your air conditioning too, but he's not really an air conditioning expert. You wouldn't really call this person if you had a major, very specific problem that was hard to solve. But if you had a general thing that went wrong with your electricity, the jack of all trades, he could come over and fix that too for you. So Hilbert was kind of like that. He was good at like everything. He didn't really specialize in one thing. He just sort of did it all. So those are things that I thought were noteworthy, that I wrote down 5 things, but you didn't have to write 5 things, but you needed 2. You might have things other than that. Anybody have something from that zone that you read and you wrote, but it wasn't something I said? So that's fine. 4 is space. We've gone 3D. So what's happening in this chapter, we're not entirely contained to the board anymore. We have some 3-dimensional stuff going on in this chapter. So then 5, you could tell me anything that you remembered from the reading. So if the person's whose paper you have is something you remember from the reading, give it to them. I thought the most important thing was probably for 3D drawings, you need to use dotted lines for stuff you can't see. That was what I wrote as my most emphasized point, but I had some other stuff on here too we'll get to in a minute. But anything you remember from the reading for 5 would do the trick. Question about what you're looking at from 3-1 sort of stuff. Okay, let's just keep talking into 3-2. So give the people their papers back. We'll cut the record in a minute. Let's add some notes now as to what's on 3-2. Again, 3-2 quiz is what's up next time that we're seeing everybody all together at the same time. When you read 3-2, 3-2 is going to have 7 points of reading. There's going to be one postulate that you already know that is repeated a second time that you'll have to say the sentence for it. It's a postulate that's already making your test and lived in chapter 2. So there's a postulate that's back, and then there's 6 other questions that are all fill in the blanks. So there are some other postulates, there are some definitions, there's some postulates that are like long enough that I'm maybe not memorizing that, making you memorize it the first day, but I'll at least throw a blank in a key spot, that kind of thing. Postulates, anytime they have a name, it's always worth knowing the name. I'm not saying that a question is the name, but I'm saying anytime there's a postulate, there is a chance that I might ask you for the name of what the postulate is. But 3-2 reading, there's 7 total new points, 6 of them are fill-ins, 1 of them is a sentence that you should already know from a postulate we've already done. Compared to today's, I still go 4 points off of today, so it's 11 total points, but the questions are different. Hilbert's going to go away. He'll be back for the test, but we don't need to ask about Hilbert every day. Number 4 off of today, I'll go backwards. I'll say, what is space? So what is space? It's the set of all points. By which I mean, I don't have to just have dots on my board, but I can be out here too. Okay, space means not just board stuff, but all stuff, everywhere. It's not just length and height. It's also, there's a depth now that we're worried about sometimes. So set of all points, that's called space. I'll follow up with the thing I did emphasize a moment ago. In sketches, the part that we can't see is drawn as blank. If we can't see something, how do we draw that we can't see it? Dotted lines. So things we can't see, we draw as blank. You fill in with dotted lines. And I'll draw you some stuff in just a second. And then I have 2 new points that are just, I think I'm making these up. I don't think these are necessarily from the reading per se. But if you're ever thinking about planes, you might find it helpful to imagine blank. When thinking about planes, you might find it helpful to imagine blank. And my word is going to be cardboard. When we start talking about planes this chapter, and I'm trying to help you picture it, I'm going to pull out like a little thin piece of cardboard that used to be a folder, and I cut it in half. So when it's time for me to talk about planes, I'm talking about blank cardboard. When thinking about lines, you might find it helpful to imagine pencils, or some similar sort of thing to that. So I can tell on this piece of cardboard, at some point there's something in this chapter where I was talking about a plane, and I was talking about a line, and it caused me to do this. You know, something was worth a discussion about lines and planes and things that could happen when they start to deal with each other, and that could happen. I see I have some planes over here that I pulled out today, slightly decorated by young Emily. I just kept it because it was already cut, I guess. But there's something that goes on in this chapter where this happens to us. You know, and planes do this for some reason. But as we go through the chapter, again, the 2 quiz questions are, when you're thinking about planes, you might want to think about cardboard. When we're thinking about lines, you might want to think about pencils. Those are questions that make the quiz. Not making the quiz, but making the test. Here's a note to write down that does for sure make a test at some point, but isn't on the quiz, is the word determine. So here's what the word determine means. It's a 2-part definition. Each sentence is medium-ish or longer. To determine a figure, there's 2 rules. It means there is a figure that can contain all the elements of the set. There is a figure that contains all the elements of a set. And secondarily, there's only one way to position it. And I'll explain the word determine more with some examples on the board in just a second. But recap, the word to determine a figure, the word determine means 1, there is a figure that'll contain all the elements of the set. 2, there's only one way to position it. So I'll go one more time through that. To determine a figure means that there would be a figure that contains all the elements of a set. And second, there's only one way to position it. And I'll hit the board in just a second and try to explain what that is. Question? Sure. Question stuff? Okay, so let's draw a cube. I'm sure on the test, one question for chapter 3 when we get there is to draw a cube. If I wanted to draw a cube, what more basic shape would I do first to get me going?
Square.
A square. Cube is made up of a bunch of square faces, so draw yourself a square. Then to make it into a cube, you want to draw the back, 2 of the sides that would be visible. If you're looking down on a box, there's parts that you can see and parts that you can't. The parts that you can't, you'd want to do dotted stuff. So we end up with 2 squares that sort of overlap, like how the Olympic rings intertwine. Okay, our two squares are gonna overlap, kind of like the Olympic rings do. One on top of the other, half visible, half not. And then you just connect the corners. You'd be able to see the tops, but this is gonna need to be a dotted line. That's a better drawing than this. If I did all solid lines, Brad. Because if I draw this, it can like do weird stuff to your eyes. It's possible that you can imagine that this square is the one that's coming out of the board. And you could sort of like roll a thing into the front of the box. But you could also imagine that this is the part that's coming out of the board. And you're going to have to kind of like throw something into the top of the box. And your eye, if you look at it, it can like sort of turn it inside out on itself, maybe not, I don't know. My eye's not yours, so I can't say that for sure. But I could take a box and it just can do that. We can draw other boxes the same way. So if I wanted to draw a rectangular prism, this is not the best drawing because I'm not going dotted. If I want to, I can imagine that this is the top of my box. And I could like throw stuff in there. I could also imagine this is the front of my box and I could like roll stuff in there and just like, it can like shift on you. I don't know if you believe me or not, but that's the truth. Second thing, if I wanted to draw a line that's going through a plane, this would not be the best drawing of a line that's going through a plane, because that looks like a line that's on a plane. So maybe this is why I broke out my pencil and my cardboard and I stabbed it. Okay, so if I wanted to try to draw like a pencil, a line stabbing through my board and touching a point, this wouldn't be great. Because what does the pencil do at some point that this drawing does not represent? It has to go through it. So there's part of the pencil right now that you can't see. So we would need to make some piece of this a dotted line. Then they had one other mild change they made to their drawing, because this is still a little deceptive. Anybody have something that they did? Memory of this? Other than making the thing dotted that went like behind. They opened up a little gap here because like this pencil right now is on top of the folder. You can't see a piece of the folder because the pencil's in the way. So they opened up a little gap just to show you the line might be in the way of the plane that's underneath it. This would mean it's coming out at you. And then the dotted stuff would mean it's sneaking on in behind. Here's some conversation about determine. 2 points determine a line. That's a fact we know. What was that fact called last chapter? 2 points determine a line. It wasn't said that way, but it's the idea. Anybody know what the name of that fact was?
Line postulate?
It's the line postulate. Okay, so here's the definitions I just gave you. If we want to determine a figure, first of all, there has to be a line that contains all those points. So is there a line that contains both of those points? Yes. Once I draw that line, is there any other way I can remaneuver that line and still touch both points? No. So 2 points has determined a line. Do 2 points determine a ray? So the first question would be, can I draw a ray that touches both of those points?
Yes.
Yes, that can be done. But is there more than one way a ray can touch both of those points?
Yes.
Yes, and you've done that on the quiz before. You've done a ray that went this way. You've done a ray that went that way. We could do a ray that starts over here and goes through them both and keeps going. There's a lot of rays that can contain both of those points. So it breaks one of the rules. So is a ray determined by 2 points? No. 1 point. Does 1 point determine a line? No. Can you draw a line that touches it?
Yeah.
Sure. But why does it not determine a line?
So you can just draw lines.
Because there's other choices. 3 points. 3 points determine a line. Depends. So depends means no. Okay, so in the world of geometry, depends means no, not yes. What do you mean it depends?
If it's like it could be a triangle.
Okay. Or it could
But
be,
then it could also be in a line.
it could be in a line. So if I said 3 collinear points, then yes, because we can do it and there's only one way to do it. If I do a triangle, we say no, because I can't even do it. There's no line that I can draw that gets them all. That's not possible. Okay, so that's what the word determine means. I think they'll use that occasionally through the chapter. To determine a figure, first you have to be able to draw it. So 3 points don't determine a line because you can't even get them all. But then once you get them all, you have to have no wiggle room. So like 2 points don't determine a segment. So even though 2 points, I could draw that segment, I could also draw that segment, and that segment, and that segment. I could sit there all day and draw segments of different size that get them. It has to be able to get them, and once you get them, there can only be one way that you're going to get them. That's our stuff. Question about 3.1, notes and ideas. Homework off of this is there's a page 50, we skip 11, otherwise we go 1 to 12. So 3.2 read for the next quiz, page 50 for the next homework, which will be due Monday for you guys as well. 1 to 12, skip 11. But if you want to work ahead, there's no reason you couldn't just plow through the homework now and just be done with it.